All right. Hey, everyone. Today, I'm going to talk to you about population dynamics and specifically, how do we measure populations? While we go through this PowerPoint, think about how we use these tools to measure the human population and how big the human population is getting. And also, using these tools, how can we predict or help some of the effects that human population has had on our environment? One of the first tools that demographers use to do population studies is something called population density. And in that measurement, you simply take the number of individuals you have of that species, so the population size, and you divide it by the unit area. Now, depending upon what details the College Board gives you, obviously you're going to use the population size and whatever unit of area they give. So it could be like hectare or acres, but that's what you would divide it by. A good example of population density or a measurement of it is Manhattan in New York City. It currently has about 67,000 people per square mile living in that area. So it's pretty dense. All right, well, compare that to Dhaka, Bangladesh, for example. There are about 23,000 people that live in 1 square kilometer in this area. And when you have a lot of people in a small amount of area, you get, for example, like the increase in disease or an increase in competition for natural resources. And I know we've been talking about humans here with New York City and Dhaka, but you can also apply this to organisms in nature. Obviously, the more crowded they get, the smaller area of space, these issues arise as well. All right, another tool that is used is to calculate the growth rate of a population. So how fast is the population growing? The variable used for this is R, and to calculate it, you simply take a look at how many organisms are coming into the population, and you take them away from how many organisms are leaving the population. So one way you might see this equation is you take the births and subtract them from the deaths, and then you add it with the immigrants minus the emigrants. Now, immigrants are organisms that are coming into the population, and emigrants are organisms leaving the population. You can also do this equation by taking the births and the immigrants and adding them together, and then subtracting them from the deaths and the emigrants that are added together. You will still get the same answer. And then you divide it by either the total population size, or sometimes the College Board is very nice and they give you a nice easy number to work with, like 1,000 or 10,000. Okay, your answer will most likely come out in a decimal form. So that's how you kind of know you did it right. And don't be scared if the number comes out to be negative. It just means that the population is shrinking. Okay, it does not mean anything else. Okay. So sometimes, and this was seen in China, for example, something happens in a population where it continues to grow even though you put limits on the fertility. And that phenomenon is called population momentum. So it's a process where the population continues to grow even when you slow down the fertility rates of the population. And that is because there are a lot of women at childbearing age, and they're going to continue to have babies until they can no longer. So for example, in China, we all know they instituted a one-child policy in 1979. So that's a very strict limit on fertility, but you still saw the size of China growing. And that is because there was such a large population of childbearing women that added to the population before it started slowing down. Another tool that is used is called doubling time. So in doubling time, what you're doing is you're calculating how fast it takes for a population to double. The unit for this, for your answer, is usually years. And how you calculate this is you take 70. So that is the constant here, 70. And then on the denominator, you have your growth rate in a percent. Okay, so for example, if the growth rate of a population was 2%, how fast would it take the population to double? Will you simply do 70 over 2. So your answer is 35 years. Things that tend to double very quickly, you'll notice they grow exponentially. And sometimes in just general terms, this is called the J curve because it does look like a J when you plot it on a graph. And just tying back into last lecture, organisms that grow this way, they tend to be R-selected. So they have lots of offspring, they don't take care of their offspring, and they tend to be the generalist species. Another tool are crude birth and crude death rates. This is how many births you have in 1 year divided by the 1,000 or 1,000 total population size. And of course, if you want to do this with death rates, you do the same thing. So you take the number of deaths that happen in 1 year and divide it by 1,000 or the 1,000 total population. Okay, infant mortality, unfortunately, is something that demographers also calculate. It is the number of babies per 1,000 that don't make it to their first year of life. Looking at this graph, this is the world infant mortality rates from 2015. I apologize, couldn't really find anything newer, but you can see the areas that are in the dark teal green sections of the world. Those are the areas that tend to have high infant mortality rates. The ones that are like a lighter shade of green, they have the lower infant mortality rates. And so you can see some of the African nations definitely have higher infant mortality rates when you compare them to, say, North America. All right, this is always an interesting study. Total fertility rate is the average number of offspring that a organism will have in their reproductive years. So here in the United States, the total fertility rate's about a 2.1, 2.3. It's on average 2. Like, right, how can you have 2.1 of a kid? You can't, it doesn't work. But anyways, so in different countries, though, it may be customary tradition to have more than just 2 children. For example, I think it's Nigeria has a total fertility rate of somewhere around 6. So that means on average, a woman will have 6 children within her lifetime. You also have replacement level fertility. So this is the number of offspring that you should have to replace both the parents. So you may be thinking, okay, if there's 2 parents, that's 2, right? So they should have 2 kids to replace the partners, the parents. However, that's not always the number. Sometimes it ranges from like 2.1 to 2.5, and that's because they take into account mortality rates, specifically infant mortality rates. All right, so a bottom underlying principle is this. If your fertility rates are at replacement levels, that pretty much means your population is going to be stable through time. So how does that work? If the number of births equals the number of deaths that you have in a population, you're pretty much going to have 0 population growth and your population is going to remain stable. So the same thing goes with immigrants and emigrants, right? If you have the number of organisms coming in equaling the number of organisms leaving, then of course your population is not going to grow and it's going to remain stable through time. So why would you want to know that information? Well, you can kind of predict or see what kinds of patterns and trends your population is going to have in the future. And then you can tie it into what sort of environmental impacts those populations are going to have in their environments. Well, that concludes a brief discussion on population measurements. I hope that was extremely helpful, and thank you so much for watching.